Hello Year 10 and welcome to today's lesson, continuing along our theme of algebra. So far we spent a lot of time factorising and solving quadratic expressions and equations, and today we're going to carry on along that theme. Make sure that you have completed the previous lesson, which was Factorising Quadratic Expressions 2, because you're going to require those skills to access today's lesson. Make sure you have your maths book to make notes, as well as your whiteboard and a whiteboard pen for any rough workings you'd like to do. To start today's lesson, can you go ahead and pause this video and have a go at the do now, and come back when you're ready to go through a couple of the answers. Okay, there are two questions I would like to look at this morning. The first is question 1. This is what we looked at yesterday, so you've had lots of practice on this. As I said, if you have not yet done that lesson, please make sure you do, as you are going to need the skills to access the lesson today. So, to factorise this, we need to first note that this is in the format of ax squared plus bx plus c. It is the general equation of a quadratic. In this case, we have that a is equal to 5, b is equal to negative 33, and that negative sign is important, and c is equal to negative 14. Next up, I need to find AC. That was always step 1 when factorising quadratics with a coefficient of x squared. AC means to multiply the two, so I'm going to do 5 times negative 14, which will give me negative 70, and that negative again is important. What I now want to do is find factors, so numbers that multiply to find AC, but I want those same numbers to add up to give me B. B is negative 33. So I want two numbers that multiply to give me negative 70 and add to give me negative 33. Factors of 70, well, one of them is going to have to be positive and one's going to have to be negative to create an overall negative answer. So we could have 35 and negative 2. We could also have negative 35 and positive 2. Now, you may have noticed there are other factors of 70. But I'm not going to write any more down because I've already realised that I found my two that sum to negative 33. So these are the two factors that I'm going to use. I now want to pop those into my original expression. I'm going to rewrite it, but instead of having this x term in the middle as one number, I'm going to split it into those two factors. So I'm going to have 5x squared, then instead of negative 33x, I get negative 35x, and plus 2x. I've taken those two factors and popped them in here, and I've still got that minus 14 on the end. These two numbers in the middle will combine to make negative 33x. This here is simplified, this is not. That's okay, I wanted to undo that simplification. Up next, I'm going to factorise in two halves. I'm going to split it down the middle just there. In this first half, I can take out an x from both of these terms, because this has 1x and this has x squared in it. But I can also factorise out 5. 5 goes into here, it also goes into here. So I'm going to factorise out 5. Inside the brackets, well, 5x times x will give me 5x squared. 5x times negative 7 will give me negative 35x. For the part on the right, I can't factorise out x, because there's only x here, there aren't any here. But I can factorise out 2. So I can factorise out 2 and I'm left with x minus 7. Now that I've noticed that these two brackets are the same, all that's left to do is to write this into brackets. I get 5x plus 2 as one bracket and x minus 7 as the other. If you're unclear on that, I recommend that you go back to the last lesson and have a look at those questions there and a few more examples on this method. I'd also like to have a look at this question down here. This asks me to use two methods to solve this equation. Now we have seen two methods. Method 1 would be to rearrange, and that's what we looked at in our first lesson back after Christmas. Rearrange to make x squared the subject. And I can do that because adding 100 to both sides is going to give me x squared equals 100. Now that all my x's are together and that they're squared, I need to take the square root of both sides to get me that x equals 10. Remembering there is also a negative answer there. So there are my two answers. X is 10 and x is negative 10. Our other technique would be to factorize. Now this is harder to do, and the thing you need to notice is that this is what we call a difference of two squares. Because we have a square number at the front and a squared number at the end. It's a difference because there's a subtraction. When factorising a difference of two squares, we take the square root of the first term and pop that at the front of the brackets. We take the square root of the second term and pop that at the end. One of them is add, one of them is subtract. This still equals 0. Now I can separate this out and say that either half must equal 0, which gives me x equals negative 10 or x equals 10. I could rewrite this as x is positive and negative 10. So there are your two methods there. Here are the rest of your answers. I do apologise for that one being there. Okay, in today's lesson we are going to carry on with solving quadratic equations, and we're going to be looking at equations where they have a coefficient of x squared. Before we start today's lesson, can you please make sure you pause the video here and write down today's date, title and keywords, and also those two recall facts. Okay, so you need to make sure you remember that when we are using the factorizing method to solve equations, the equation must always equal 0. If it doesn't, we have to rearrange it. For example, if we were asked to solve this, we cannot solve this by factorising yet. We must make it equal 0 first. We must subtract 7 from both sides to get 2x squared plus 4x minus 7 equals 0. Now we can start to use some methods that we've previously used. So I'm going to go straight ahead and start with an example. We must make sure it equals 0, and it does, so we've satisfied that. And I want to factorise first. So step 1 is to factorise. Now, these are going to take you slightly longer to factorise because of the fact that we have a coefficient of x squared. So they are going to take you slightly longer, but that's okay. It's still the right method to use. So I want to find AC. 2 times 18 will give me 36. I now want factors of 36, so two numbers to multiply to equal 36. And I want those same numbers to add up to 12 in the middle there. Thinking about the numbers we're going to use, we could have 9 and 4. We could have 6 and 6. 6 and 6 are going to add up to 12, so those are the two numbers I'm going to use. I'm now going to take these two factors and separate bx, that middle term, into two separate terms. So I get 2x squared plus 6x plus 6x plus 18 equals 0. Now I want to factorise in two halves. I'm going to take out 2x from this side, leaving me with x plus 3. And for the second half, I'm going to factorise out 6. Okay, remembering to keep that equal 0 there so that we haven't changed the question that we started with. We're just looking at it in a slightly different format. Now I want to factorise this fully by splitting it up into brackets. So I get 2x plus 6 and x plus 3 equals 0. I now need to recognise that at least one of these has to equal 0 for the equation to work. So either 2x plus 6 equals 0 or x plus 3 equals 0. And you're used to that. Yes, there is a number here, there is a coefficient of x. That's okay. We still follow the same method. I now want to rearrange these. So on the right one, I get x equals minus 3. And on the left one, I get 2x equals minus 6. Dividing by 2 gives me x equals minus 3. Now you won't always find that they are the same answer. It may happen every now and then. That won't always be the case. Can you please pause the video here and write down this example? And please have a go at the one on the right. Okay, on that last step there, I have skipped solving these two equations. I'm just going to show you the one on the left. The one on the right is what we've been doing a lot of. For the one on the left, I get that 2x plus 8 equals 0. This is a two-step equation I need to solve. I subtract 8 from both sides to get 2x equals minus 8. And then divide by 2 gives me x equals negative 4. One thing to note here is you may end up with fractions in these questions. That's okay, we can have fractions as answers. Okay, I'm going to show you this example here. So we still want to factorise, and we're going to use the AC method. AC is going to be 2 times 15, which gives me 30. So I want two numbers to multiply to 30 and add to 13. Factors of 10 could be factors of 30 could be 15 and 2. Could also be 10 and 3. These two numbers here add up to 13, so I'm going to use those ones. Splitting bx into two terms gives me 2x squared plus 10x plus 3x plus 15 still equals 0. Factorising in two halves, I get 2x, x plus 5, plus 3, x plus 5. Splitting into two brackets, 2x plus 3 and x plus 5. Each of these must separately equal 0 for the full equation to work, so I get that 2x plus 3 equals 0 or x plus 5 equals 0. This is going to be x equals negative 5. The one on the left, subtracting 3 from both sides, gives me 2x equals negative 3. Then I need to divide by 2, and I get that x is equal to negative 3 over 2. You could write that as a decimal. There's really no need to, as a fraction is just equivalent. Please pause the video here and write this down as an example. And please have a go at the one on the right on your own. And there's your answer. Okay, alternatively, we could have a quadratic that looks something like this. It's got an x squared, it's got a bx, but there's no c. So this is different when I factorise it. I'm not going to separate this into two brackets. I can't. It's not possible because the second I use, for example, the AC method, and I take a is 1 and I multiply it by c, which is technically 0, I then can't find factors of 0 that add up to give me 16. So instead of using the AC method and factorising like this, I'm instead just going to look for common factors of both terms. Well, x squared can be written as x times x, and 16x can be written as 16 times x. Looking at these, you'll notice that both of them have a common factor of x. So I can factorise out x, which then has to be multiplied by x to give me x squared, and it has to be multiplied by negative 16 to give me negative 16x. This is now equal to 0. This is split into two factors. It's not in your standard factorised form of a quadratic because it's not got two separate sets of brackets, but technically I could write a bracket there and I now have two brackets. So I know that to solve this, I need either one or both of those brackets to equal 0. Otherwise, if they both don't equal 0, then you're not going to get 0 as an answer. So as long as one of them is 0, you will get 0 as an answer when you multiply them. So we know that either x is equal to 0 or x minus 16 is equal to 0. This one on the right tells me that x must be 16. There are my two solutions. So when you don't have a plus c on the end, you instead need to factorise by taking a common factor, and it's likely to involve an algebraic term of both terms to then be able to solve it. Please pause the video here and write this down as an example. And have a go at the one on the right, please. And there is your solution. Okay, please have a go at these questions. You will need to pause the video and have a go at each of the questions. Be careful when you get down to the questions I'm going to put a star next to, as you may need to think carefully about them. Question 12 I will go through once you've had a go. Okay, for question 9, you would have needed to have expanded these brackets and simplified it, then subtracted 40 from both sides to get it to equal 0. Equally, for question 11, you would have needed to subtract 50 from both sides to get 2m squared minus 50 equals 0, and then you can start to try and solve that one. Alternatively, you could have instead tried to isolate m squared by dividing by 2, and you'd get that m squared equals 25, which tells me that m is equal to positive and negative 5 when I take that square root. For question 10, we haven't looked at how to factorise things where you have a negative x squared, and I personally don't like it. It is possible, it's not very easy to do. I would have instead added x squared to both sides to make it positive on the right hand side. I'd have added 16 to both sides to move the 16 across, and I'd have subtracted 8x from both sides. This would give me a new equation where I'm left with 0 on the left hand side, and that would equal x squared minus 8x plus 16. Then you can start to solve that one. For question 12, I'm going to solve it up here on the right as I need a bit more space. I first want to expand both sides. I cannot combine any like terms. I can't set anything equal to 0 until I have all the terms on one side and those equaling 0. So first things first, I'm going to expand both sides, which is going to give me 10x squared plus 4x plus 5x plus 2. That's on the left hand side. On the right hand side, I've got 2x squared minus 4x minus 2x plus 4. Combining like terms, and I'm also going to try and squish this onto one line now, I get 10x squared plus 9x plus 2 equals 2x squared minus 6x plus 4. Now this is a much easier format to work with. I now want to set it equal to 0 on the right hand side, or I could have done the left. I'm going to choose this side to end up equaling 0, so that I only end up with positive x terms. To do that, I need to subtract 2x squared, I need to add 6x, and I need to subtract 4. That's then going to cancel out these terms, this will cancel out these two terms, and this will cancel out these two terms. And I need to do that to both sides. So I'm going to be doing this to both sides. This is the calculation I'm doing. 10x squared minus 2x will give me 8x squared. 9x plus 6x is going to give me 15x. And 2 minus 4 will give me negative 2, and that now equals 0. Now you have a quadratic equation that is in the correct format. It equals 0, and you can now use the AC method. Okay, I'm going to load up all of the answers now for you. On these questions, where I've given them as decimals, if you've given them as fractions or vice versa, that's absolutely fine as long as they're equivalent. Okay, you've come to the end of today's lesson. Can I please ask that you make sure that you take a photo and upload your work to Frog using the file drop button, and also complete today's quiz, which you'll find attached to the assignment. Any issues uploading or any questions you have, please email me. You'll find my email address in the assignment details.